Welcome everybody. Thanks again for being here for Rocket Q&A, our twice a week Q&A. Today we are super lucky to host Nino Ulsamer, who is the CTO and co-founder at StashAway, one of the leading wealth management and robo advisor platforms in Asia. Nino has founded StashAway with his team in 2016 and has since grown StashAway from 0 to over 200 employees and roughly 50 engineers, is what I could tell on LinkedIn. So Nino has a wealth of experience building a team, building a product from the early stages, growing into its more mature stages that StashAway is in today. Prior to StashAway, Nino was also a CTO and co-founder at several startups, mostly in e-commerce and logistics, from what I could tell, across Germany, Russia, and Singapore. And he's been doing that for over 10 to 12 or 10 to 15 years from what I could tell. And Nino, we're super lucky because Nino is also an angel investor in Rocket Academy. So he's a supporter of Rocket Academy, hopes to get some good graduates and good software engineers from Rocket Academy. So I hope we can deliver on that by applying to StashAway after we graduate as well. Cool. Nino has prepared a short presentation for us today. He's going to be sharing a bit. So I've taken some feedback from student requests in the past weeks. I know somebody had requested for fintech security topics. So Nino's going to talk a little bit about fintech security. He's also going to talk a little bit about the technical challenges that the team has faced at StashAway, things that we may not experience in the bootcamp, such as architecture and scaling considerations. He's also going to talk a little bit about the processes of deploying code in production at StashAway that we may not experience in the bootcamp as well. So I'm super excited to learn from Nino and to have this discussion today. So Nino's going to be sharing a short presentation for about 15 minutes, after which we will jump into the Q&A. I'm going to share the standard typical Pigeonhole Q&A link in the Zoom chat. So feel free to post the questions there as Nino's presenting or after the presentation as well. Cool. Awesome. Without further ado, I will hand it over to Nino.
Perfect. Awesome. Let me get the sharing started. 1 second. Does this work?
Yes.
Yes. Oh, perfect. Hold on. Sorry, guys. Let me just rearrange this a little bit so we can see you folks. Okay, perfect. Yeah. Hi, everyone. Nice to meet you all. And thanks for the introduction, Kai. Yeah, I did also prepare a bit of a self-reflection on the next slide. I guess you can go through that super quickly, given you already mentioned a lot of this. But yeah, as Kai mentioned, I'm what you could call a serial entrepreneur. So StashAway, I think it's company number 7 that I founded, with a strong tech background. So been usually in the tech co-founder, CTO role or adjacent to that. And I'm currently co-founder, CTO of a company called StashAway. So StashAway, as a super 10-second intro, was founded in 2016 in Singapore. We're a retail digital wealth manager. The emphasis on retail is important because, as we were going to later talk about, security, this has an impact on what it means for us to how we operate and what do we need to take care of. And it was kind of important from day one, really, of founding the company. So there's some implications of that. We are currently operating in 5 countries, Singapore, Malaysia, Dubai, Hong Kong, and Thailand, and also therefore regulated in those 5 countries. And currently, we're actually already at about 80 folks across the product engineering teams, roughly, and growing from here. So yeah, as Kai said, obviously, we started from 0, and so I can share, I guess, how that journey looked like and how the focus also shifts quite dramatically from the different stages of the company. Right? All right, without further ado, let me maybe jump right into it. So first of all, I guess I wanted to highlight a little bit of this, right, which is maybe as an introduction to the rest. So if you look at our career progression framework that we rolled out inside StashAway, these are actually all the different skills that we evaluate people on. So this is used during performance evaluations that we do twice a year, but also when we assess people as we hire them. We have sort of seniority levels for different engineers. and to assess people, right? And as you can see, writing code, which I'm assuming is a lot of the things that you do as part of the Rocket Academy, is one thing, which is always important. But then, as you can see, actually, as an engineer, a lot of other things are equally important as well, right? So just to put things into context, I think it's always good to remember that. The first topic I wanted to dive a little deeper into is the topic of system architecture. So when you think about writing code is kind of one thing, and obviously it can take it can take part in the matter of a very small scope of just a function in the scope of a larger service. But then the more kind of the complexity of the domain that you're working in, it keeps growing. The more important actually to also think about not just every single line of code, but also to think about where do you actually put that code? How do the different pieces all fit together? And that's actually a very, very challenging thing to do, especially in the beginning when you're starting out and you're literally starting from a blank slate, and you need to kind of get it right, because if you don't, you're creating a lot of problems for the future. So some of the things, right, that are important here, maybe you've heard previously of a concept called domain-driven design. So the idea here is to say, okay, I'm letting my architecture being guided by the domain that I'm operating in, right? And so I'm trying to really follow the sort of the real world principles, and the idea, and why is that? Because ultimately you're going to probably interact in some form and shape with those entities in your code at some point in time, right? And because it's very hard to predict what exactly the functionality you're going to have to be building, a year, 2, 5 down the road, it is useful to just stick as much as you can to kind of the principles that the domain that you're operating in provides you, so that you can, that there's no kind of strange surprises, that you haven't built the wrong abstraction layers and you need to build something new. All of a sudden, it doesn't fit into whatever you've built so far, right? So that's an important principle to kind of keep in mind, which then leads you sort of to the next point, which is kind of as you write your code, not just in isolation in a function in a single service, but as you move towards splitting your code across several services, it becomes very important to think about where is the boundary, right? So let's say in just a simple example of I have now not just 1 but 2 services, you need to decide obviously where a certain piece of functionality sits, and these boundaries are extremely important. And again, it's ideal. You use the first concepts of the domain-driven design to let you guide there. And then it's also important to think about the interfaces between these different services. Ideally, the interfaces should be stable. So you ideally build services in a way that you can kind of treat them as a black box from the outside, meaning you don't need to really understand all the complexity and intricacies of whatever the service is doing inside. You can just follow the definitions that the interface gives you from the outside to use that service in some other shape and form. And when you talk about just 2 or 3 services, this may seem not super important, but as the number of services grows and as the number of engineers working on these different services is growing, it just becomes more and more important. And the reason is simply that you don't have, as a new engineer, for example, that joins StashAway today, there's dozens of services, right? And you don't know what they do. I mean, you don't have any of the context. You haven't been with a company since day one, so you don't know what's actually inside. And so the ability to reason about what a service is doing and being able to make certain assumptions on that from the outside without having to kind of go and read code by line inside becomes more and more important as the company grows. So that's another important piece. And then related to that is also the question about how do these different services communicate. So there's always some examples, like you have an API, a REST API, for example, that gets exposed by a service. That may sometimes be the right choice, but sometimes not, right? So you need to think about, in the bigger scheme of things, do you want to have, for example, a synchronous communication path where a particular call from the customer kind of gets routed through different services, or does it actually make more sense to have something more asynchronous where you usually end up with a higher degree of robustness? Because if one service in this chain isn't working, if this is all one synchronous call, your entire, this call kind of can blow up very easily, right? By just one piece not working. While the more you move to an asynchronous communication style, the more robust services become. So this is one consideration, for example, that becomes important. And then lastly, also, this will then end up guiding your team structure, right? Because I'm not sure if you've heard of Conway's law before, but basically, it basically just says that, the structure of your team will kind of reflect the structure of your code or services or architecture or vice versa. And the reason is that because teams, ultimately your code is being written by people, right? And people communicate. And so, the teams that you form, if that doesn't equate, so if the teams that you've formed are different from the services that they're working on, then you end up with a lot of friction actually being created, because people will need to go to another team to ask a question or something, or they don't understand the service and vice versa. And so it's in an ideal scenario, you actually have those two things evolve together, so that you reduce communication friction along the way. So that's on system architecture. Now, as Kai mentioned, I also wanted to briefly touch upon, how does it now look like in practice when we write code, and from sort of a line of code that's being written, what happens next, right? And so this is a super high level summary, of course, but just to outline. So first of all, we have different environments, right? Where you can think of a developer environment that's just a local laptop, right? So you write your code locally, you test it, you do certain things. This is the actual development process, right? Next, you would deploy it to what we call a staging environment that we usually have for each of the countries, where you can actually test and see in a bigger scheme of things, with like other changes that may have been made in the meantime, and all the other services, and you can kind of test the whole thing. And this is oftentimes where also maybe a product manager comes in and says, okay, let me actually check out this piece of functionality that you built and make sure it works correctly, right? And then from there on, we would then eventually deploy to production, for which, like I just mentioned, we also have different environments by country, actually. So there's 5 production accounts in AWS, each serving one of the 5 countries I mentioned. Now, in terms of where you would actually write your code, so there's a branching strategy that we follow that is based upon what we call feature branches. So, you usually have a master branch in Git. You branch off for a particular feature, and then you merge it back into master, and then we will deploy into production environment from the master branch. Now, the important aspect here is these feature branches are supposed to be short-lived. So don't work like on a gigantic feature for like, several weeks, and then you create a merge request where you merge this code back into master. Someone needs to review it. If the person's like, oh my God, like I have to review 10,000 lines of code, impossible, right? So we try to keep, and then also at that point, other work may have been merged into master, which leads to conflicts, right? So you want to kind of keep that as sort of short-lived as possible. So I'm talking about ideally less than a day type of lifetime, right? So you merge your code back kind of immediately, actually, in as small chunks as possible. And then from there, as I just mentioned, we deploy it into production. There's an important notion here that we're not allowing developers to just deploy any feature branch to production. This has obviously there's a process reason behind this. Like it would obviously get really messy, and you don't know anymore at what point what is actually sitting in production. But there's also a compliance reason for this, because this would also allow any developer to just go and deploy random stuff into production, and this would kind of be not compliant from the regulatory guidelines that are in place. We can't allow that, because obviously that will allow you to screw with the application. And since we're handling customers' money, we need to be extremely careful with all these things. And then lastly, we're also, you may wonder, if you're merging code so frequently, how can you actually do that? And the challenge is obviously that, and then the deployment to master should ideally happen immediately afterwards, right? So you kind of shipping code all the time for production, but then you may not be able to actually build a bigger feature within just a couple of hours, right? And so what you do for that purpose is sort of use feature flags, which means that you the code is already in the product, but it's not yet visible, right? So you're turning it off in a third-party application. You still ship it, and then when you're ready, and you enable it for your internal employees, for example, or for the product manager, whoever wants to look at it, right? But then only when you deem the feature ready to be released to production, you kind of flip the switch, and then it immediately becomes visible to all customers, right? So this has multiple benefits, and one of the key ones, of course, is that you can be a lot more, you can basically drive your testing process in a way where you can test things on production. In our case, this is also, again, important because it's hard for us sometimes to simulate things properly because we're dealing, again, with money. Once customer gives us money, we need to buy certain securities. There's pricing. A lot of this stuff happens in the physical world, right? It's very hard to simulate all of this. And so it's important for us to be able to kind of do things in production without interfering, of course, with other customers or without releasing a feature that's not yet ready for launch, right? All right. So yeah, that's a brief overview of how code gets basically into production. Now, the final point I wanted to talk a bit about is security, as mentioned by Kai. So security for us is driven by different principles. So of course, on the one hand, security is important for any company, but in our case, as I mentioned, we're regulated by 5 regulators. And in Singapore, for example, we have the technology risk management framework that we need to adhere to, issued by the MAS. And that means that, and that's actually been the case from day one, right? So this is not something that, became important, after we reached a certain size or we've made sure we have achieved product market fit. This was something we had to do from day one to even get the license to operate. And there are certain principles that need to be in place. So the never alone principle is what I just mentioned, right? So the example that I shouldn't be allowed, even me as a CTO, I shouldn't be allowed to just write code and put it out into production. The issue is not allowed. So the way we do this is you write the code. You cannot actually push to master, right? The only place you can push in Git is a feature branch, which then gets merged back. And for the merge to happen, someone else needs to actually approve. So that's kind of the way we do this. For example, there's certain recovery time and recovery point objectives to be met. So that means that, what happens, if the system crashes, right? How long does it take you to get it up and running? And at what point of what recovery point objective basically says, like how much data are you allowed to lose in that? So if you need to, for example, restore from a backup, and the backup was taken an hour ago, so you're losing kind of an hour of data potentially. Is that okay or not, right? So there's certain timelines you need to adhere to here. Backups itself, of course, and testing of backups, equally important than taking the backup. You need to be sure you can actually restore from your backup. Disaster recovery. So this is, again, the process of testing all these system scenarios, not just, hoping that nothing's going to go wrong, but actually preparing for the worst case and continuously putting this to the test. So these are all things that we need to kind of follow from day one. Some more general approaches that follow from there are what is called shift left. I don't know if you're familiar with that term, but basically just means that you try to automate as opposed to writing your code and doing everything and releasing everything and then figuring out in the very end that, oh, actually there's a problem, it's not working, and then you got to go back all the way and restart doing the thing. You try and do as much of that as early in the development process as possible. And in this case, some examples here, so you can scan for vulnerabilities in your code. In the case of Node, you can do it, for example, with the Yarn audit. There's a thing called static application security testing, where again you apply certain there's a software solutions that basically can look at your code and tell you, hey, there's a risk for a particular type of attack here in this code, right? So there's certain things that you can just certain basics you can cover by just deploying certain software solutions as part of your deployment pipeline. So every time the code, for example, you create a merge request, these pipelines will run and will actually check the code to make sure you're not introducing any vulnerabilities. There's also certain cloud security capabilities, of course, that you can leverage. So in our case, we're hosted with AWS, and AWS has a couple of stuff. So for example, we're using CloudFront, which has a kind of a web application firewall built in. That means actually this piece of so CloudFront is basically just taking the traffic from the customer, routing it to your service, and in the process, it can do certain things. And it can, for example, check for certain injection attacks, or can perform rate limiting, so you make sure you don't overload certain of your endpoints at this point. So stuff like that, right? And or there are also other providers that can provide denial of service attacks and things like that, right? So there's a certain external capabilities, I guess, that you can leverage. There's also a very important topic of access control. So this is, I'll say, also partially covered as part of the technology risk management guidelines, where there need to be certain processes in place. So let's say, as an employee, how do you actually gain access to a certain service? What's the process for that? How you document it? How can you prove it to the auditor that this was someone actually approved this request and things like that? There's obviously then that leads to a kind of a role-based access system where you want to make sure that you have different roles for people and they only get really the access they require, and not everybody's an admin, basically, right? And therefore can see customer data and stuff like that. And that also then translates into certain difficulties when you, especially in the beginning, when you, for example, you can't give a developer will not have a production database access, right? And that means, if something goes wrong, it gets a bit iffy to really figure out for a developer, hey, what actually happened, right? And so we have certain processes in place that anonymize our production database, put it into the staging environment that I mentioned earlier, so that we can also use the staging environment for testing, or for reproducing issues that have happened in production, without the developer actually seeing the real data. Names, for example, will be replaced with different random names and stuff like that, right? So that there's certain things we do for that as well. And then, lastly, final point, also certain assurance elements that are happening as part of the security. So audits I just mentioned are a regular occurrence for us in the various countries. Pen testing, so penetration testing, means you hire an external group of people that will try and break into your system, and you can do this on various levels. You can do this in a black box form where they act like an attacker would, and they don't know anything about your system, and you just try from the outside and see what they can do. It can be a white box where they actually have the code and they can look at the codes, try and find certain vulnerabilities, and then try to exploit them, and then any mix of those, of course. There's also a bug bounty programs which are required under the MES as well, which means that you basically pay security researchers to find bugs in your, or not bugs, sorry, but security vulnerabilities in your application. And if they find something dependent on the severity of the issue, they will you'll pay them a bounty. And all the way to red teaming, where you do something similar internally, right? So you will for example create an internal team that tries to play the adversary and try and break into the system, do certain things, and you have another team that's kind of trying to I guess defend or react, and you kind of test. Again, it's just a way of testing, I suppose, the internal process that you have in place. Yeah, again, super high level overview, let me maybe stop here, and we can move to any questions that you guys have on either the topics we just talked about, or of course also anything else that you guys are curious about.
That's an important link there on the on this slide. So I'll save this for when we graduate. Cool. So I just reposted the pigeonhole. So for those of us who have questions, feel free to post and upvote the questions that you most want to ask. I can kick it off. So thanks, Nino, for sharing. You can feel free to stop sharing any slides whenever you're ready. And if we have questions, we can go back to them later. How much do entry-level engineers need to know about all of those things that you talked about?
Right. So, for example, if you go back to that slide I showed at the beginning, right, which basically shows the different skills and things like that. The entry level, right, so the seniority level 1, for example, obviously it does have a much higher focus on writing code as opposed to some of the other things like system architecture and all the other dimensions we mentioned. So I would say we don't really hire so much for the particular experience we have with a certain technology, as much rather the potential that we see in candidates. And for example, as part of our hiring process, we do go through a couple of case studies, and the case study are more, I would say, designed to test your overall ability to to think and also observe a little bit of how you collaborate and things like that, as opposed to saying, oh, you need to I don't know, write a function in this language and whatever, right? So we try to be a bit agnostic, because otherwise we feel it's not really, again, experience at some point maybe for more senior roles may become important in some areas, but more often than not, what we more care about is actually the soft skills that we'll be evaluating during the interview, and then on the more technical side, more sort of the ability that you can show in a case study to work out together a problem with someone else from the team, as opposed to short answer. These are all things that I would say, I think it's part of the learning journey, right? As a career path at StashAway. And so definitely not something you would need to be all familiar with as an entry-level role.
Yeah, I guess since we're on the interview topic, maybe I can dig a bit deeper there. You were talking about case studies. Do you think you could elaborate a bit more about what, I know that you don't want to review the exact interview questions, but I'm just curious, like what a case study might look like and what a candidate might be expected to do in a case study.
Yeah, we usually start with some kind of a take-home assignment, and it depends a little bit on the role, and we try to cater a little bit for what the candidate already has experience with. For example, if they're more front-end heavy and they want to do something in React, or it's something more full stack and things like that. After which we will usually proceed to a case where we walk sort of through a database architecture on our side. So we'll basically present a process flow, and then work out together in a live interview, how we would design a database architecture to cater for that. And then
the process, like a user process flow, like someone's going to use the app this way. Okay.
Yeah, correct. And then finally, we usually, and during that interview, we also try to determine which team likely would be a good fit for you, depending also on your preferences and your background and all of that. And then in the following round, we'll usually try to set you up with one or two engineers on that particular team, and do another round that goes more into team fit and maybe some technical details and things like that. And then that's it usually, right? So yeah, that's roughly how it looks like.
Nice. Okay, so sounds like a lot of the coding is done up front in the take-home assignment, and then there's some collaborative design thing that happens with engineers.
Correct. Okay. Exactly. Yeah.
Okay. Just while we're on this topic, does anyone have any follow-up questions on interviews? For many of the other, so one of the things that we do at Rocket to prepare for interviews is algorithms. And so we know that many companies, especially the larger ones, they focus a lot on algorithms problems like your leak code or HackerRank type problems. How does that fit in, if at all, with StashAway's interview process?
It doesn't really. So we used to do them. We used to do these type of tests in the past for a while, for a period of time, and we didn't find them very predictive in terms of whether whether the candidate, for example, we had them before this database interview that I mentioned, instead of what we now do as a take-home assignment, and they weren't like very, it didn't really help in a sense, right? So the people that, I don't know about the people we filtered out, but the people that passed, it was a really mixed quality. So I'm not a big fan of those algorithmic type of things. I do understand it might be necessary to prepare for, given that a lot of companies do unfortunately have it as part of their hiring process. I'm personally not a big fan of them.
Got it. Okay. Thanks for sharing about that. All right. Can we shift gears a little bit? I would love to chat a bit about, because I know that StashAway, it's been 6 years, 2016, time flies. And I would love to hear more about the challenges that you guys face at the earlier stages when you're 0 to 10, because some of us might be joining startups afterward, and the challenges that the company might have faced when it was, say, 10 to 50 engineers. Just to give everyone perspective, when we're thinking about what companies want to join, what can we expect at companies of different sizes?
Hmm. Yeah, I think so if I look back kind of at the first year, right? So 2020, or let's say a year and a half, right? So from 2016 to end of 2017, the team was very small, right? So we're talking about now 0 to 5, 6 engineers, that kind of size. Obviously, you're like, yeah, it's fun, right? Because you're sort of starting from scratch, and you can kind of look at all the cool technologies and whatever, right? And you don't have any of the tech debt to deal with. You don't have customers to deal with, right? You just code, and it's a fun time, right? And also working really, really hard. So in our case, and I think that's the case for any startup, at that stage, right? I mean, you just gotta like get shit done, right? I mean, you gotta launch as soon as you can. You're gonna have maybe some troubles raising funds. You may have to cut back in your salaries. Like, it'll be tough, right? But then I think it can also be super rewarding, right? If you make it through that period, you can grow personally. It can be financially rewarding, right? Some of the people that joined very early on, as you can imagine, they have now a very, very large stock option package. I mean, compared to people who join now, that it will be a lot smaller, obviously. And so one day that can be worth a lot of money. So I think it can be a super exciting time, but also very intense. And it is also, while now we're around about maybe 60 engineers or so, right? And now obviously you have support structures in place, right? So if you join the company, there will be a team lead, there'll be a team, there'll be people you can learn from. There's certain things in place, code you can look at, and so forth, right? So to orient yourself is going to be a lot easier than in an environment where you have nothing, and everybody, like, there may be other senior folks in the company, but they're busy like doing coding and whatever, right? You don't have a lot of structure in place. So I think that may not be the ideal place in my mind for if you don't have a lot of experience, because you may be struggling a lot, right, in terms of picking up skills, and the pace of growth on a technical level may actually be slower, right, than compared to an environment where you have experienced people around you. I would say then there's a phase in between, so somewhere, I don't know, maybe around about, I don't know, when you grow over the size of maybe 10 people, up to 25 or so on the engineering team, right, where I think it's a lot of things need to change, because you start in this super hacky environment, and you kind of you just like I said, right, everybody just gets their shit done and whatever, and it's not very organized, right? And but then when you cross at some point the team size becomes too big, you need to actually start organizing things, otherwise it's just not going to work, and with too many people it's going to become a mess. And that is hard, right? Because now you need to create a lot more structure, a lot more process, a lot more forming the teams, right? Maybe breaking down services. So this can be technical challenges, can be people challenges. So I think that's an interesting period. And once you've gone through it and you've come to maybe a size of 15, 20, 25 engineers or so, likely there will be already a lot more structure in place, right? And then I think from that point forward, it can be actually great to be in a smaller company rather than a larger. I mean, the larger than the company gets, just, I guess it's the function. It'll be just more and more structure, right? And I think structure can be good and bad, right? I mean, structure can obviously help as you grow and you require guidance, but it can also prevent you a little bit, right, in terms of growing faster. So I think the exciting piece about being in a young, small company, for me, is that if you get it right, if you find the right company, the growth trajectory can actually be very fast, right? Because your scope of responsibility can grow a lot faster than you would otherwise be possible if you're joining a larger, more established company and need to kind of go through the career ladder and everything, right? So I would say at StashAway we're probably now somewhere in between, right? So we're not all the way like super formal corporate, of course, but we're also not anymore like a scrappy startup, right? So it's probably somewhere sitting in between.
Awesome. Thanks for sharing that. My kind of question that was upvoted on Pigeonhole he was asking how many engineers, how big is the software engineering team? You mentioned earlier it's around 60 right now. But I also had a related question related to the slide earlier where you were talking about organizing teams by services. I'm curious, how is StashAway organizing the teams? Is it by services, or how are the engineers organized right now?
Right. So we have what we call a tribe and squad structure. So we first kind of started out with a front end and a back end team. And then as I was growing to maybe more than 10 people or so, we were kind of like, we needed to kind of restructure that, and we introduced squads. So then we said, okay, we have for different type of functionality, right? We'll have a different team handling that. And then as that evolved and more squads came up, we started introducing tribes. So basically a squad for us as a product manager, a designer, and then a handful of engineers inside. And then a tribe contains several of those squads. You usually have an engineering manager on leading the entire tribe and coordinating the different squads, and then you have a lead product manager doing the same on the product side. So we work very, very closely between product and engineering. In fact, both of the functions still report up to me, and then we again, it's a bit more, I would say it's either feature driven or in some cases also kind of maybe more metric driven, right? To say, okay, we want to have a team that focuses more on customer acquisition, for example, and how we can improve that and things like that. Yeah.
And then are there specific teams for, say, cross-feature functionality, like whether it's DevOps or security?
Right. So forgot to mention. So for sure. So there's a platform team that basically takes care of the overall infrastructure, DevOps, and things like that. There's also we also introduced what we call chapters. So chapters basically are technology driven. So there's, for example, a mobile chapter, and that chapter will be coordinating, I don't know, for example, the release process of the mobile app. How to, you have because it's a single mobile repository, right? But quite a few developers from the different squads are committing code into, making sure we adhere to certain best practices and standards, reviewing code and so forth, right? So
yeah, wow, it's complicated.
Yeah, exactly. So but it's evolving, right? So this is a development that we kind of started, I think, in 2020 to introduce the squads for the first time. And then about a year later, maybe we started introducing the tribes, and now start introducing chapters. So it's kind of a step-by-step function, right? But it does end up in a pretty complex overall piece, right? But 80 people is also a fair amount of people that need to be kind of put together to coordinate, right?
Yeah. Continuing on this theme of the technical aspects, Jiachen had a top voted question. Jiachen, who's here, he's one of our section leaders at Rocket Academy, and he's joining Facebook as a software engineer later this year. And his question is, at Facebook, they have a gatekeeper, which is a tool to build feature flagging. And he's curious to know how StashAway does feature flagging at scale, because he hasn't seen many good open source alternatives. Jiachen, feel free to add on to the question as well.
Yeah. We're using a tool called config.cat for feature flags, which is good. I mean, we quite like it actually. It's not super expensive, and it does scale well for what we do, because it's actually evaluating on the client side or on the application side. Instead of every call kind of being made to config.cat, the service will once fetch sort of the toggle and then receive from time to time updates, but all the flag evaluations are all done locally, so the scalability is not a problem with that. That's what we're using. But there's plenty of other tools there. I guess not sure about open source, right? So these are all paid tools, some more, some less expensive.
Jiachen, does that answer your question? Oh. Nice. I guess he's at school. Nice. Okay. And then pretty cool question by Dewey. What is the toughest feature your team had to tackle so far? And I'm sure there are many. How did they overcome it? And how long did it take to get the feature ready as planned?
That's a great question. I guess it's hard to rank them, I guess. I would say one of the most complex pieces that we are building in our stack is what we call our trading system. So this is basically the piece that takes a deposit, rebalances the portfolio puts it into a portfolio, rebalances the portfolio, creates trades, executes the trades, and all that. Right. So kind of the back end type of functionality of it all. And it's complex because you're dealing with a large number of customers, individual customers, but then we're having these aggregation points. So for example, let's say if you have 100,000 customer portfolios and you rebalance them, and then you create trades, right? So let's say you have certain ETFs that you need to buy or sell due to the rebalancing action of a portfolio. We then go for a certain day and aggregate all of those orders into one single order that we send to our broker. And then when the result comes back for that trade, once it's executed, we need to again go and then distribute it across all the customers. And that's actually a non-trivial problem when you do it at scale, right? So there's a lot of edge cases that at first sight it seems like not that difficult, but when you go into the details of it and you have different type of orders and you have buying and selling, and then some of our products are ETFs where we buy and sell certain number of units, and then you need to set limit prices, price limits, price changes throughout the day. You have other funds, which are money market funds, where the mechanics are very different. And so, and then putting that all together into one kind of algorithm that can deal with it all is actually very difficult. So I'd say, and then there's a technical challenge to the system too, because you want to make sure everything is auditable. You understand that if if something goes wrong, we're accountable, right? So we're holding the ledger. We're the source of truth for the question: how many units of this ETF does this customer have? And we can't mess it up. I mean, right? So so there's a lot of kind of built-in, like we use a concept called event sourcing, which basically means you're storing, all the, instead of just storing, for example, the number of units you have over time, you want to rather actually store the sort, so the buy and sell and actions like that, that you can then use to always recalculate the number, so that in case something is off, you can always retrace your steps and say, where did it go wrong? As opposed to, if you one day discover you have 6.5 shares and you say, actually should be 6.4, you're like, okay, I don't know what happened, right? So, so those kind of mechanics are built in there, right? So it's a very complex piece of software and covers a lot of functionality. So yeah, I would say that's probably the most difficult one. It's less. Yeah, we did in the beginning when we built. So because the second part of the question, I guess, is how long we got to build it and did it go to plan and things like that. I mean, this was obviously built. We needed that to go live. It was obviously built in a rush, and as you can imagine, and then and we did push the team to go live maybe sooner than everybody was comfortable with, and it did end up causing a fair amount of problems initially as we launched. None of them were actually visible to the customer, but because of the event sourcing approach that I mentioned, we were always able to understand where did things go wrong and kind of correct things behind the scenes, make sure everything is correct, is right. But it was a very stressful period for the team because obviously you're trying to, at the one hand, you're struggling to address the operational problems that happen. At the same time, you want to, of course, fix the problem that why does this occur in the first place, and then you need to build new features. So it's like a pretty stressful period in the beginning. So maybe we launched a little bit too soon on that. I mean, looking backwards, but yeah, it is what it is. But yeah, that was pretty difficult. And yeah, we worked probably from first developer. I mean, I am excluding myself now, but right from first developer hire to launch, it took us probably around 6 months or so, right? 6-7 months back then. So we did not have a lot of time given all we had to go.
Yeah. Dewi, do you have any follow-ups? Do you have any follow-ups to that question?
No, I think he really gave a very detailed answers, and thanks for sharing lots of the the experience with us. And I think, for me, especially coming from a non-coding background, this has been very valuable to know how a company starts and how you arrange your team and how you, like you said, nothing is ever as fast as you want it to be, and you have to sometimes rush the team.
Yeah.
I think we can all relate to that.
Yes, still today, still true today, right? So I guess never changes.
Yeah, I'm having a headache just thinking about this algorithm and all the different data types you gotta handle. Yeah.
Yeah. Thanks for answering my questions.
Yeah, for sure.
Yeah, and so you must need to. I mean, it sounds like it's super crucial. I mean, it's like life and death for the company to get these numbers right. How does the team make sure that the team gets this right? Like, is it just you have your star engineers like making sure that this is there, or is like what processes are in place to make sure that this doesn't screw up?
Yeah, I guess in general, also as I guess the company matures, you can less and less rely on, those infamous 10x or star engineers or whatever you want to call them. I think there may be something that can be very valuable in the very early days when you have like just a handful of people and everybody just like goes out and on their own and just builds stuff. I think over time it becomes more and more important to form proper teams, right? And a team is not just a random collection of individuals. A team needs to work well together. You need to make sure you cover certain different functions. You have different backgrounds in the team. You make sure people actually work together on solving problems. So you employ practices such as pair programming and reviewing each other's code and knowledge sharing and all of that, right? A lot of communication. That's why, right, when you look back to the evaluation metrics, a big component is communication, right? And the way you communicate and keep each other in teamwork and collaborate is extremely important the more the team grows. And so I feel like that's a more important aspect of it, right? I guess and then you try the other angle of it is obviously process, right? So you can try and enforce certain things by making sure that you test certain scenarios, you do certain things before code goes out into production. You have certain measures in place to understand when something goes wrong. You understand it quickly and so forth. On this particular trading system I was talking about, we, for example, have certain reconciliation methods in place where we will compare. We basically do sense checks from the outside, right, and make sure that everything adds up, that nothing strange has happened. Do some sanity checks and so forth. Unfortunately, we didn't have this system from the launch. That would have saved us a lot of the early pain of fixing problems in the middle of the night. But yeah, then over time there was an obvious kind of addition to the system that now we're very confident that something like that obviously wouldn't happen anymore. But would if it happens, we'll get caught kind of immediately before it causes any further damage.
Yeah, awesome. I'm well. That sounds like a real lifesaver to have the system. I'm glad that it happened. Justin has a question. And so, Justin, I'm not sure if I think we talked a bit about the interview stuff at the beginning. Justin's question was, approximately how long does the interview process take at StashAway for a junior engineer? So Nino was mentioning earlier, there's a take home, and then there's some DB design interview, and then some one or two engineer interviews with engineers afterward. But yeah, maybe Nino can elaborate a bit more.
Yeah, it mostly, I would say, depends on the availability of the candidate. So I would say we're more often than not, we're not really the bottleneck here. So I would say it can go very quickly, right? So as I mentioned, there's a take-home assignment, and obviously it depends on the candidate how fast they work on that. And we review that usually very quickly within a matter of very few days, and then from there on, it's usually a matter of just coordinating availability across candidate and interviewers, which let's call it. It can, but oftentimes it can be done within a week, let's say, right? So then that maybe takes the overall process from kind of evaluating the application to, in theory, it can go very quickly, right? So it can take kind of like 2 weeks or so. I would say in average maybe a little bit longer than that, just because of a bit of back and forth on communication and things like that. So yeah, but yeah, somewhere maybe between 2 to 4 weeks, I'd say.
Justin, does that answer your question? Cool. And Chuanxin has related. So Justin and Chuanxin, they're currently still interviewing. There's some offers, but I think they want to see if they can interview us apply to StashAway as well. So Chuanxin has a related question about the interview sessions that we were describing earlier around the take home and then DB exercise, and then the two interviews or the interviews with engineers after that. Would it be possible to elaborate a bit more about what StashAway is looking for in those sessions? I know you mentioned communication and collaboration, but is there anything more? Yeah.
So yeah, I think in the take home assignment, obviously it's more on the result, right? So we will look at the code, we will look at how it's structured, how it's written. Also, I would recommend, this is true for any coding exercise you may receive with a company, I would recommend go beyond at least what we appreciate a lot at Candidates is if you go beyond the mere code, but you say, okay, what I'm submitting, you're submitting more than just a couple lines of code, right? You're also submitting, for example, an explanation around what you did, like maybe a README file. Did you write tests, right? How did you structure the whole thing? Is it presentable? Is it, what does it look like, right? Do you have a diagram in there, maybe whatever, right? So I guess look at it as a package, we're not just evaluating the technical lines of code. We're looking at, is this properly formatted? Does this look good, right? Is this a solid overall package, right? And I think that's important for any submission, right? So this is true even when we interview for non-technical roles, for C-suite roles in the company, and someone applies and sends us a case study, and it looks like there's not enough attention to detail and effort put into just a visual impression. It's not good, right? I would urge you guys as you go through interview processes, any deliverable that you give, like look at it like with an eye of, hey, is this like, am I proud of this, right? I want to look at that. Does this look like nice? Not just like, because then we oftentimes hear the feedback when we give feedback to candidates about that was maybe not good enough, then they're like, oh, but I answered your question, right? It's like, yeah, but it's not just about the content, it's also about the presentation, right? So I think keep that in mind. And anyway, so I think that's something we look out for both in the take-home assignment, but also in the later rounds, right? And also factors such as how do your appearance on the what do you wear, right? A lot of the stuff happens virtually these days, but you can still wear different things, your posture, your whatever, right? Like, sometimes people show up in like random noisy cafes. It's hard to hear them. You're not doing yourself a favor, right? So I think all of that is important. Then the things I mentioned already, of course, communication and especially during the live kind of case, it shows a lot. And also, how do you react, right? So what if you get challenged? How do you react? Do you insist on your opinions or not? Obviously you need to be the right balance, right? You need to kind of have a point of view, but maybe also not hold on to it for dear life. So I guess all of that. Analytical skills obviously are important as an engineer, in my opinion. So and maybe also math skills to some extent, right? So it's not like we're not going to ask like super tough math questions, but they're just small. Like, how are you comfortable with handling numbers, let's say, right? And things like that. So I think those are all the things that are being looked out for, I would say. Yeah. And then obviously a big part is also the motivation, right? So in general, like why do you apply? Why here and not somewhere else? Like what really motivates you? Because ultimately, I think if you have, that's kind of the combination of the two, right? So what I mentioned earlier, that it's important for us, more the raw material is more important to us than necessarily the exact set of experiences you have. But then combining that obviously with the right motivation and the urge and the learning, the desire to grow, then that's always important, right? So if you have all the raw material, but then you're not using it, then that's also no point, right? So I think the motivation and the raw materials need to come together for you to be on a growth journey. And I think that's especially important for people that are doing like career switches and things like that, right? Because you need to kind of show that you're eager, because you're only at the beginning, right, of your learning journey, and you need to be able to show that you're gonna go a lot further than that, right? So the motivation aspect here, I think, is a very important one, and to demonstrate it in whatever ways you can.
Francine, does that answer your question?
Yeah, thank you so much.
Awesome. All right, we're coming up to the end of the hour, so I'm going to be combining a few questions to wrap up a little bit here. So Mike has a upvoted question about bootcamp graduates, and so he was saying, among your 60+ development team, do you have any bootcamp graduates or many bootcamp graduates, people who may not have studied computer science? And related to that question is, what can bootcamp graduates or people who did not study computer science best do to prepare themselves for software engineering roles and succeed in the job?
So yeah, I think we do, for sure. We do have people, actually a lot of people, I would say, that don't have a computer science background. I don't. I mean, if you put together what I said earlier, right? I don't actually care what you study, right? I mean, what I care about is how you perform in the interviews, and I think you can honestly, even if you don't have any business background. I mean, I'm calling it a case study, but at the end of the day, you don't really need to know databases for it, right? So I think that is kind of definitely very open to any kind of a background, right? And therefore we end up having quite a few people with mixed backgrounds in the team. To answer the second part of the question, I guess how to best prepare. Nevertheless, I think for me it's I think like I mentioned earlier, right? Because the writing code is only like one small piece actually of the puzzle, and so the more you can show that you actually kind of understand the full thing, like you also understand how to run code in production, that you understand how to, I don't know, what a proper Git branching strategy looks like, how you deal with the ticketing system and so forth, right? The broader kind of outside of just writing code, you can also understand the scope of the job. I think that helps a lot, right? Because it'll be important in your day-to-day, and if you can demonstrate during interviews that you already at least know what the challenges are, and maybe haven't like used all of it before, right? And haven't not the expert, but at least you are aware of what are the things, and you can also show that you've already kind of studied them and things like that. I think that can help quite a bit, in my opinion. Yeah.
So, okay, I think unfortunately we're out of time. So I have to really thank Nino for his time with us today. Thank you, Nino.